This video will walk you through setting up feed verify for a relay. In this example, we want to set up feed verification for an inhibitor pump. This example has the inhibitor pump on relay number 1. So we're going to open up the property page for this inhibitor pump. So I'm going to double click on the icon there. And the property page opens up. I go to the control tab. The control type, I select meter, and the control by, I want to select sequence. And now I need to tell the multiflex to turn on the inhibitor pump when it reads 100 gallons on makeup meter on the input O. Turn off the inhibitor pump when it reads 15 milliliters from the inhibitor meter on input P, or otherwise known as the verify meter. So at this point, if I were to click apply, all this information will be sent back to the controller, and the controller has everything it needs to know to turn on the inhibitor pump and to turn off the inhibitor pump. And just to reiterate, the inhibitor pump will turn on when it reads 100 gallons from the makeup meter and turn off when it reads 15 milliliters from the inhibitor meter. But in the multiflex world, feed verification has added features. And to see what those added features are, we will go to the feed verification tab, enable feed verification, and this simply means enable these extra features. It has nothing to do with disabling or enabling this area. So the first thing that we need to do is tell the multiflex where is our verify meter. Well, we've already told it that it's on the meter on P, the inhibitor meter. The next feature, or the main feature that feed verification in the multiflex does, is it will calculate ppms of your inhibitor within the tower system. It calculates ppms based on one of 3 different types of methods. The first method being fixed cycles. If I know the fixed cycles, I'll just type in my cycles. Let's say the cycles of the tower is 2.7, and that's it. I'm done. However, if I don't know my fixed cycles, or if I don't know my cycles, and I do have a bleed meter, I can select meter cycles and then select the bleed meter. On this system, we happen to have a bleed meter on input Q. And the way the multiflex calculates ppms using this method is it will use the ratio of your makeup meter, which is defined over here in the control tab, the first part of the meter sequence, as you may recall. That's our makeup meter. And we tell the multiflex where our bleed meter is, and the multiflex will use the ratio of those 2 values to calculate ppms. Now, if I don't have a bleed meter, and I do have a bleed relay, then I can use bleed cycles for my ppm method. And I tell the multiflex where my bleed valve is. In this case, it's on relay number 9. And this is the most trickiest to set up out of the 3. The reason why it's the most trickiest is because the only way that the multiflex can calculate ppms using the bleed relay is if the bleed relay has a control equation that specifies a ratio of your tower conductivity and your makeup conductivity. So let me just go show you what that control equation looks like in order for this bleed cycle type or ppm method to work correctly. So let me cancel out of here, lose all those values, and I'm going to go to my bleed valve. Notice that's on relay number 9. I'm going to open up the property page here on the bleed valve, relay number 9. Select the control tab. Control type will be a sensor type. I want to select the tower conductivity divided by the makeup conductivity. And it's important that the tower conductivity goes prior to the makeup conductivity. And then I specify the set points. Turn on at 35 microsiemens, turn off at 2800 microsiemens, and then I click apply. So assuming that I set up a control equation like this on the bleed valve, let's assume I just clicked apply, then I can go back here. Let me just jam right through this to get us back to where we were. Okay, now we're back to where we were here. So the bleed cycles, if I choose the bleed relay here on the bleed valve, or if I choose bleed valve number 9 for the bleed relay, and we had that ratio of conductivities defined in this bleed relay, then the multiflex will be able to calculate the ppms correctly using the bleed cycles. So that's mandatory that you have the bleed relay set up correctly for its control equation in order to use this method. That's why it's the trickiest. But to keep things simple, we'll just use fixed cycles in this example. Say we have a cycle of 2.5. And now lastly, we tell the multiflex where to store these values. And the reason why we want to store these values is so that we can create Trackster reports at a later time. So the ppm values, let's say we want to store on input D, and we want to store the inventory, let's say on input J. And so now we click the OK button. So what's happening in here is the multiflex will store the ppm values here in this location and the inventory values in the input J. And after we've set that up, we may want to go to the sensor D, where our ppms are, and just rename it so it's easy to look at, user-friendly, if you will. So now we have this inhibitor ppms, and the sensor J was our inventory. So let's just inventory, and we have gallons. And the offset is how we can calibrate, if you will, how many gallons are currently in the tank. So if I happen to know that there's currently 45 gallons in the inhibitor tank, then this is where I want to specify that value in the offset of the sensor. So now click OK. And now it's a little easier to read, where we have inhin, misspelling, it should be inhib, inventory. I can name it anything I want though. And then I calibrated it to be currently at 45 gallons. And this will continually go down as the inhibitor pumps more inhibitor into the system. And that's it for feed verification.